Hi friends, in this video, let's see how to train a given input vector in auto-associative network. So here is our question, and let's uh, consider this given input vector as is, that is 1, 1, 1, 1. And what does this auto-associative network means? The network in which the training input and target are the same. Such network is called auto-associative network. So the first step, we have written our given input vector, and then now we have to compute the weight. So the weight is computed with the sum of product of the transpose of our given input vector into our given vector. So that means here is S is our input vector, right? So we will be getting our weight value with this S transpose into S. So our S transpose is 1, 1, 1, 1, and our S is 1, 1, 1, 1. Now, with this, the final weight value will be 1 minus 1 minus 1 minus 1 minus 1 1 1 1 minus 1 1 1 1 minus 1 1 1 1. Fine. Now let's go to the question. What have they asked is, see, test the network for the same input vector. So, in our first case, we will be testing the network for the same input vector. Let the test vector be S bar. So the same input vector, right? So 1, 1, 1, 1. Now, how we need to test is, we have to calculate net input value. For that, we have to manipulate our test vector into our obtained weight, so that we will be getting into 1 minus 1 minus 1 minus 1 minus 1 1 1 minus 1 1 1 minus 1 1 1 1. If we simplify this, we will be getting minus 1 minus 1 minus 1. So minus 4 plus 4, again plus 4, and again plus 4. Now what we need to do is, we have to apply the activation function. So since the input vector is in minus 1 and 1s, we will be applying bipolar activation function. So the bipolar activation function is like, I'll be writing here. So y is equal to f of y in, and it is 1 if y in greater than 0, and it is minus 1 if y in less than or equal to 0. So after applying our activation function, our y is minus 4 is less than 0, so minus 1, and the 3 4s are greater than 0, so 1 1 1. If you see here, our obtained y is equal to our initial input value. So we have obtained the correct response. Hence, correct response is obtained. So if we test with the same input vector, we have obtained the correct response. Now let's see. Test the auto-associative network with one missing value. So now let's test our network with one missing value. So let this be case 2. So our input vector minus 1, 1, 1, 1. What we have to test now is we have to miss one value and we have to test with that obtained resultant input vector. So let me miss this first value. So our test vector becomes 0, 1, 1, 1. So now let's find y in again. So S bar into W, right? So 0, 1, 1, 1 into 1 minus 1 minus 1 minus 1 minus 1 minus 1 minus 1 1 1 1 1 1 1 1 1 1 is our weight, right? Now let's simplify this. We will be getting minus 3 and 0, 3, 3, 3. If we apply the activation function, we will be getting minus less than 0 from minus 1, 3 greater than 0, so 1. So this is also obtained correct response. Now, see, out of these four, we missed first value, right? So now let's try with second and third and fourth. Okay. Now see, let's miss second value. Our initial input vector is minus 1, 1, 1, 1. And if I miss the second one, our input will become minus 1, 0, 1, 1. Now find y in. So I will be writing here y in is equal to S bar into W. So minus 1, 0, 1, 1. W 1 minus 1 minus 1 minus 1 minus 1 1 1 minus 1 1 1 minus 1 1 1 1. So if we simplify this, minus 1 1 will be getting minus 3 and so 3 3 3. So if you apply activation function, we'll get y is minus 1 1 1 1, which is equal to our input. So correct response. Now miss the third value. Our initial input is this, and if I miss the third one, our test input will be this, and let's find y input. Net input value will be computed like this. So 1 minus 1 minus 1 minus 1 minus 1 minus 1 1 1 1 1 1 1 1 1. So if we simplify this, minus 1 minus 1 0 minus 1, so minus 3 and plus 1 1 plus 2 plus 1 3 3 3. So in this also, if we apply activation function, we obtain correct response. And let's test by missing the fourth input value. Our initial vector is 1 2 3 4, and if I miss the fourth one, our test vector is 1 1 0, right? And our net input will be computed like this. So W value minus 1 1 1 minus 1 1 1 minus 1 1 1 1. So if we simplify this, minus 1, so same as before, minus 3 3 3 we will be getting, and if we apply activation function, we will be getting this. So correct response. So the conclusion with this is the network uh, produces the correct response, though one value got missed. Okay, and now let's go to the question again. Next, one mistake value. One mistake value in the sense we have to change if it is -1 in the given input vector, we will be changing to +1. So doing such mistake for one value. Now let's see. One mistake. So our initial thing is -1 1 1. Let me make a mistake on first value. So our test vector will be, I'm changing this -1 to +1. So 1 1 1. And now let's find the net input. Yeah. So yn is equal to our test vector into our weight. So our test vector is this, and our weight is this. 1 minus 1 minus 1 1 1 minus 1 1 1 minus 1 1 1. So if we simplify this, our net input is 1. So minus 3 plus 1 minus 2 2 2 2. So now apply the activation function for the obtained net input. So -2 is less than 0, so we will be getting -1, and 2 is greater than 0, getting 1. So here also we obtain correct response. So similarly, try for the rest of the things, like let me make the second value mistake. See, sorry, this is our initial vector. If I make the second value mistake, minus the 1 1. So now let's find yn. So -1 -1 1 1 multiplied with our weight. And 1 1 1 1 1 1 1 1 1. And this -1 plus 1 and -1 -1 -2 and 1 -1 and 1 plus 1 2 2 2. So here also, if we apply the equation function, we will be getting correct response. And so similarly, you do check for the rest of the two values by changing each sign and making a mistake of one value, and see whether you are obtaining correct response or not. And coming to the next further part of the question, they ask you to check for 2 missing values and 2 mistake values. So I will be not performing of all the combinations to balance it. So you do try testing all those. Let me do for 2 missing values. Now, 2 missing values means what we will be doing is we will be skipping 2 values out of those 4 in our given input vector. Here I have done one mistake value only for 2 values, 2 combinations. You try for the further combinations too. And coming to two missing values, our given input is minus 1, 1, 1, 1. And here I have done mistake value two combinations and we have obtained correct response. It doesn't mean that if you mistake the if we provide mistake for the rest of the two entries too, for with that also we will be obtaining correct response. Uh, it is not like that. We have to check whether it is giving correct response or not. If two combinations got successfully correct response, it doesn't mean the rest of the two also will be getting the correct response. We have to test that. And coming to two missing values, let me miss these two. First two, our input vector, test input vector will be 0, 0, 1, 1. And let us find in value is bot dot w 0, 0, 1, 1 into 1 our weight value minus 1, 1 minus 1, 1. So if we simplify this, we'll be getting 0, 0 minus 1 minus 1 minus 2 0, 0, 2, 2, 2. So if we apply the activation function, we will be getting minus 1, 1, 1, 1. Since minus 2 is less than 0 and 2 is less than 0, and we have obtained the correct response. Correct response. And now let's try another combination. I will be trying only two combinations. We will be having more than two combinations. The further combinations, please do try it. So I'm doing missing second and third input values. So sorry. This is our given input. If I miss the second and third, our test input will become this. So let's find yin is equal to s bar dot w 0, 0, 1, 1. So minus 1 double 0, 1. And our weight is minus 1, minus 1, minus 1. And 1, 1, 1, 1, 1, 1, 1. So minus 1, 0, 0, again minus 1. So minus 2. And plus 1, 1, 2, 2, 2. So here also we have obtained correct response. So please do check for further combinations too, like missing the first and fourth value or first and third values, or second and fourth values. So check all those combinations and see whether you are obtaining correct response or not. If you miss two values in the given input vector. And for the final part of the question is to test the two mistake entries. To one mistake entry, we have changed one value in the given input vector. Now we are going to perform mistake for two values. So our given input vector is two mistake values. Okay. Our input vector is minus 1, 1, 1, 1. So I will be testing the first two. So if I do mistake for the first two values, it will become 1, minus 1 and 1, 1. So now let's find net input s bar dot w. So 1, minus 1, 1, 1. Into our weight value minus 1, 1, 1, 1, minus 1, 1, 1, 1, minus 1, 1, 1, 1. So, if you multiply 1, 1, 2, 2 minus 2, you will get 0. And again, minus 1, minus 1, minus 2, and 1 plus 1, 2. Minus 2 plus 2, 0, and these two are the same, right? 0, 0. So, it means our y will be, since our y net input value is having all the values of 0, our obtained y value will become 0. If it is equal to 0, we will get minus 1, right? So minus 1, minus 1, minus 1, minus 1. Did we obtain correct response if we perform two mistakes in the given input value? No. So we didn't obtain correct response. So like this, you have to test your associative network with the given conditions in the question and check whether you obtain correct response or not. If not, that particular condition is not suitable to train the associative network, auto-associative network. So this is how auto-associative network is used to train the given input vector. Thank you.